two questions that some of you have struggled with on your momentum unit assignment that I wanted to touch on right now. Not to give you answers, but just to give you a little bit of a hint if you are struggling with it. First one is multiple choice question number 14. This relates to some data on the previous page. Talks about this Mars polar orbiter moving at 5,000 meters per second, ejecting a short burst of fuel perpendicular to its direction of motion. Let's draw a picture for this. Let's say the Mars polar orbiter is the object right here. It has a mass of 629 kilograms, as was given to us on the previous page, and it has a velocity of 5,000 meters per second. We'll say that it's moving to the right. We don't really know that, but we know that it's moving. We can just choose which way we're drawing the direction. We'll say that it's moving to the right. This is going to be my explosion point here, the explosion that releases the burst of fuel. As we release the burst of fuel, it's released perpendicular to the direction of motion, right? Perpendicular to the direction of motion. So if the object is moving to the right, then the burst of fuel after the explosion might go down this way. Now, it might go up as well. It doesn't really matter. We're only trying to find an angle, not a south of east or north of west or anything like that. So it doesn't really matter which way we draw it, as long as it's perpendicular to the original direction of motion. Now, object number one, which is our burst of fuel, we don't know its mass, but we do know its momentum. It's given to us as 1.37 times 10 to the 5 kilograms meters per second. If the burst of fuel goes down, well, then the orbiter is going to continue moving to the right, but it must also go up. So object number two, which is our orbiter, is going to go up and to the right after this explosion. Ultimately, it's this angle that we're trying to find right here. We're also told here that the mass of the orbiter did not change significantly. So we're going to say that the mass of the orbiter, although it is a little bit lower technically, it's going to continue to be for us 629 kilograms. Ultimately now, you're going to do your x and y components. You're going to find the angle. You could find this value right here as well. But in the end, all you're trying to find is the angle. So resolve it into x and y components, and then draw a right angle triangle and find your angle as we always do. The next question that I've received a few questions on is numerical response number 3. And it's found on page 15 of your unit assignment. It relates to the information on page 14 that has a graph of speed versus speed, final speed versus initial speed. You see a bunch of data points here. If you wish to know that you're ultimately going to need the slope of this graph, if you wish, you can draw a line of best fit by hand and then find the slope of that graph the old-fashioned way by saying rise over run. That works just fine. But there is a little bit of a cheat, which isn't really a cheat because it's a function that's built into your calculator that allows you to avoid doing all of this by hand. If you want to do it the old-fashioned way, be my guest. If you want to do it the calculator way, this is the way you'll go about doing it. Firstly, I want you to identify the x and y coordinates of each of these points. I'll identify the x and y coordinates of the first point and the last point just to show you how it's done. And then you would do the rest, enter them all into your calculator, and then your calculator would spit out the slope and the y-intercept for you. The first one, you can see that the first one has an x-coordinate of 1.4 and a y-coordinate of 0.4. The last one has an x-coordinate of 6.2, 6.4, and a y-coordinate of exactly 3. Again, you would find the x-coordinate and the y-coordinate of all of them and enter all of them into your calculator. I'll show you how it's done with only 2 data points, however. So on your calculator, you're going to hit the stat function. Now at the top of it, you see 3 tabs, Edit, Calc, and Tests. You're going to click on Edit and pick option number 1. You're going to see a data table that's likely going to be clear. If there is numbers on it, then simply delete those numbers. Now I want to enter all of my x points, 1.4, 6.4. For you, it would be a number of other points as well in between. Now we go to the y coordinates, 0.4 and 3.0. Again, you would have a number of other points in between. Now what I want you to do to find the slope and the y-intercept of this graph is to click Stat again. This time, you're going to scroll over to the second tab, which says Calc. You're going to scroll down to the fourth option, which says Linear Regression, LinReg or Linear Regression. Click it. Now on a TID3, you're going to have to click it a couple times. On a TID4, you're going to have to click it 3 or 4 times. Click Enter. You can see the equation, y is equal to ax plus b, and it says the value of a here, for me, is 0.52, and the value of b is negative 0.328. So the slope of this graph, for me, is 0.52, and the y-intercept, for me, is negative 0.328. For you, it's going to be different because for you, you're going to use all of the data points, not just the first point and the last point. Once you have the slope and the y-intercept, then you're going to tackle this question effectively like we've tackled those other questions where we've used a graph, the slope and the y-intercept of a graph to find something. Like in the lab that we did, it was lab number 1, I think.